Friends, we are discussing or learning mechanics, properties of matter and sound. This is the big title of our paper for semester first. Now we will start the next topic, that is elasticity. Up to last lecture we have been studied about the mechanics. In mechanics we have discussed the pendulum, how the acceleration due to gravity calculated, interchangeability of the compound pendulum, then Kepler's pendulum, afterwards Newton's law of gravitation, and by the help of it we have discussed the different cases for calculating gravitational field, gravitational potential, and now we will see the elasticity. See, elasticity is the property of a body when we are applying a force. At that time it changes its size and shape, and after removal of it, it regains its original shape and size. This property of the body is known as elasticity. Now see, in first lecture also these things were discussed, that in this semester for this paper, mechanics, properties of matter and sound, these are two chapters, mechanics and elasticity, having a much more base of 11th and 12th. Not only base, but you have studied the much more part. Now in detail we are going to study here, and therefore we will discuss the introductory things for the elasticity. See, elastic properties of matter. An elastic body is one of that returns to its original shape after the removal of the force and is known as elastic body. See the golf ball. Here is the golf ball, and when the stroke is given to golf ball, it changes or it returns to its original shape after removal of that stroke. This is a rubber band. This rubber band we oftenly used to bound the currency notes or another documents. This rubber band is also used. This is a saucer ball. The player giving a stroke by his leg to the saucer, and therefore again due to property of elasticity, its original shape and size gets deformed. Then the question is, what are the elastic properties of a matter? Then an inelastic body is one that does not return to its original shape after deformation. Means that it having a hardness, and even though we are going to apply the force, then it does not return to original shape and after a deformation. This is a duff or a braid. Applying force. Then in a regular we can say experience, we having a chapati. We applies a force, then it takes a shape of chapati. But after removal of that force, it does not get its original size, shape and size. Again, this is a clay. Means a modeler, he uh, makes different type of models by using a clay. At that time, he applies a force, but after remove this force, it does not return to its original shape and size. This is also in case of inelastic ball. The same thing happens here. See, once again, we are discussing here very basic things which you have been discussed in previous classes. Then what is elastic or inelastic? Elastic collision loses no energy. The deformation on collision is fully restored. And at the time of inelastic collision, energy is lost and the deformation will be permanent in this way. An elastic spring. This spring, this is a F force applied to this spring, and due to this force applied, this spring is displaced or it take a deformation through the distance x, and it is the example of elasticity. Therefore, a restoring force. This is also one of the important concepts for getting the idea in next equations, the restoring force. F acts in the direction opposite the displacement of the oscillating coil, and therefore here F equals to minus of A into x. Minus sign due to the F acts in the direction opposite to the displacement. Opposite displacement takes in this way and force F, yes, in this way. Then see, in 11th standard we have learned the Hooke's law. An important law in concern with the elasticity. By Hooke's law, when a spring is stretched, there is a restoring force. That restoring force is proportional to the displacement. Therefore, F is directly proportional to the displacement, and with a negative sign. Why negative sign? It is against the force, and K is nothing but the spin constant, and it is given by this. Again, stress and strain. These terms is also important for the study of elasticity. Though you have been studied stress and strain in previous classes, but here we will just review the terms as we have been reviewed for the mechanics. The terms, that is nothing but the gravitational field, gravitational potential of mass, and all these things. In that way, here we are discussing stress. What is the stress? stress is nothing but a concern to the cause of a deformation, and strain is concerned to the effect of the deformation. See once again, stress is the cause of deformation and strain to the effect of the deformation. The downward force F causes the displacement X, thus the stress is the force and the strain is the elongation. See once again the difference between the stress. Stress is nothing but the applied force and strain is the elongation. That is, the X is the elongation. Yes. Now automatically the next question arises that what are the types of stresses? See, there is a tensile stress which occurs when equal and opposite forces are directed away from each other. Then the tensile stress occurs in this way. When equal and opposite forces are directed away, this is a rigid support. To this rigid support is a weight, tension is given, and force is applied in opposite directions. Here the tensile stress occurs. Then compressive stress, when equal and opposite forces are directed towards each other. See, here the force, this force is applied towards each other, and therefore to the body here the compression gets. See now, stress is the ratio of an applied force F to the area A over which it acts. Now strain is the relative change in the dimensions or shape of a body as the result of an applied stress. The example of stress is strain, that is a change in length per unit length and change in volume per unit volume. See, for this we know the experiment which we have been studying in 12th or so, Young's modulus by Searles. At that time there is a change in length takes place. This now longitudinal stress and strain. This is the diagram for getting the idea of longitudinal stress and strain. Just we are doing the experiment. Here wire, rod and bars, there is a longitudinal stress F by A. That is a area that produces a change in length per unit length. See, this is a rigid support. To this rigid support, this is a weight. This having a length M. Deformation gets by delta M. And see, the elastic limit is one of the another concept. The elastic limit is the maximum stress a body can experience without becoming permanently deformed. Means that for any type of object there is its limit. Up to that limit we can apply the force. Afterwards, though that body having the property of elasticity, but it cannot get regain its original and shape. In this way, we can see here this is a force WW applied, and due to which there is a mm, his body is permanently deformed. If the stress exceeds the limit, the final length will be longer than the original period. See, this is a 2 meter long, and therefore this example is uh, out of a limit we have been given or I applied the force, and therefore it does not show the property of elasticity. The ultimate strength is the greatest stress a body can experience without breaking or rupturing. In this way, this is a length that is 2 meter. We are applying a force and due to it which is deformation. This stress is given by F by A. If the stress exceeds the ultimate strength, the spring breaks. Means this is a nothing but damage. Now these things are for having an idea about the elasticity. Now the most important part means article by article or concept by concept we are approaching towards our syllabus. Here the modulus of elasticity or moduli of elasticity are important. See, there are bulk modulus, Young's modulus, and modulus of rigidity. These are three modulus which we have to see.